We all look up and see a blue sky, right? I mean, it's one of the most basic facts of life. But what if I told you that's actually a beautiful illusion? Today, we're going to uncover the real color of the sky, and trust me, the answer is probably not what you think.
So let's just get right to it. Why is the sky blue? You've probably heard the classic explanation, something about the ocean's reflection or light scattering in the atmosphere. And that scattering part, it's a huge piece of the puzzle, but it is definitely not the whole story.
Okay, here's the big twist. The sky isn't actually blue. From a purely physics standpoint, the color that dominates our daytime sky is violet. Yeah, really. So the real question isn't why is the sky blue, but why do we see blue when it's actually violet? And to answer that, we have to start with the source, sunlight itself.
Now, sunlight looks white or kind of yellowish to our eyes, but that's a bit of a trick. In reality, it's a cocktail of all the colors of the rainbow, all mixed together and traveling as light waves.
The best way to think about it is that our atmosphere acts like a giant, planet-sized prism. You know how a little glass prism can take a beam of white light and split it into a beautiful rainbow? Well, our atmosphere does the exact same thing. It separates that sunlight into all its component colors, because each of those colors travels in a very different way.
So every color has its own unique wavelength. Red and orange, they have these long, stretched out, kind of lazy waves. But as you get to the other end of the spectrum, blue and especially violet have these really short, choppy, high-energy waves. And believe it or not, this difference between long and short waves is the absolute key to everything.
So what happens when this whole jumble of light waves slams into our atmosphere? Well, they start bouncing off stuff. It's basically a giant game of cosmic pinball up there.
Now, the scientific name for this pinball game is Rayleigh scattering. Our atmosphere is just full of trillions and trillions of tiny little gas molecules. And it turns out, these molecules are the perfect size to knock around those short wavelength colors. Yep, blue and violet.
So here's how it plays out. As sunlight pours in, those long red and orange waves just kind of muscle their way right through. But the short blue and violet waves, they get bounced around by those gas molecules in every direction you can imagine. They scatter all over the place.
This scattering effect is what floods our entire sky with that blue and violet light. So wherever you look, you're seeing those scattered waves. But hang on, this brings us right to our big paradox. If violet light has an even shorter wavelength and scatters even more than blue, why on earth don't we all see a big violet sky?
I mean, all the physics points to a violet sky, but obviously that's not what we see. And the reason for this has nothing to do with the sky anymore. It has everything to do with us.
That's right, the final piece of the puzzle isn't out there, it's in here. The color we actually perceive is a team effort between the physics of light and the specific biology of our eyes.
See, inside your eyes, you've got these tiny color detectors called cones. And we have 3 types of them. We've got cones that are sensitive to red, cones for green, and cones for blue. Notice anything missing from that list? We don't have a specific cone that's designed just to pick up violet.
Now, here's our first big clue. The sun doesn't shine all colors equally. It actually sends out a lot more blue light than it does violet light. So, right from the very start, there's just more blue light up in the sky to begin with.
And then there's clue number 2, our own biology. Our blue detecting cones are just naturally way more sensitive to blue light than they are to violet light. So of the light that does reach our eyes, we're just built to register the blue part much more strongly. Our eyes are basically cheering for Team Blue.
So you might be wondering, how do we even see violet at all? Well, your brain has this really cool little trick. It turns out that our red cones can actually pick up a tiny bit of violet light too. So when your brain gets a signal from both your blue cones and your red cones at the same time, it interprets that combination and says, oh, okay, that must be violet.
So, you put it all together. There's more blue light coming from the sun in the first place, and our eyes are way more sensitive to it anyway. The blue signal just completely overpowers the violet one. Our brain takes in all that info and makes the final call. Yep, the sky is blue.
Now, what's really cool is that once you understand this, you can use the exact same science to explain another amazing sight, a fiery red sunset.
The big difference between noon and sunset is simply how much atmosphere the sun's light has to travel through to reach you. At midday, it's a pretty short trip straight down, but at sunset, that light is coming in at a really low angle, so it has to slice through way more atmosphere.
And on that extra long journey, pretty much all of that short wavelength blue and violet light gets scattered away before it even gets close to you.
So the only colors that can survive that marathon trip are the long wavelength ones. The reds, the oranges, and the yellows. They're the only ones left to paint the horizon. So when you boil it all down, what's the big takeaway here? Well, it's that the colors we see in the world aren't just out there. They're an interpretation, a story that our brain creates for us.
The sky is, in fact, filled with scattered violet light. That's the physics of it. But because of how the sun works and how our eyes are built, our mind constructs the experience of a blue sky. Color is really that meeting point between objective reality and our own perception.
And it really makes you wonder, doesn't it? If our brains are capable of editing something as fundamental as the color of the sky, what other parts of our reality are they quietly shaping for us without us ever even noticing?